I made 4. How many did I use up? 2. I made $4, spent $2 doing it. That gives me a net change of 2. So the end product of glycolysis is 2 pyruvates and 4 ATPs, but I gained 2 overall. Doing okay with glycolysis? Yes, no, indifference?
Yes.
Yes. Biology 1 as well, right? Mm-hmm. Okay, we did glycolysis. We made pyruvates. What's next? What's after I make pyruvates? Krebs cycle or citric acid cycle, but actually it isn't true. Because we need to do this. We have to convert our pyruvate into something else. Let's do that over here. Hey, where's the pyruvate from? Over there, right? Glycolysis. So we take our glycolysis, we're going to take our pyruvates, and magic's going to happen. And what are we going to make from all this magic? Acetyl-CoA, which is a nice molecule to know. And we're going to make something else. What else do we make besides acetyl-CoA? NADH. And CO2. And CO2. So this is the main one I'm interested in, acetyl-CoA. So we just did a little conversion step. Okay, on my pyruvate to acetyl-CoA. Now you can say Krebs cycle, because now we're going to start the Krebs cycle, or citric acid cycle. So unfortunately on this one you do have to know them all. So you have to know all the intermediaries.
Wait, before we go to Krebs cycle, can you, I know this will make sense in about 3 seconds, but why do we have a net of 2? Are we talking about both molecules of pyruvate in the end?
Yes. So let's do a per glucose number. So you start with 1 glucose, and you make 2 pyruvates, and each one gave you 2 ATPs.
Where on that slide you had before, there was like 2 coming off at one point, and then 2 coming off at the other point. So that's
they just
4.
didn't show you the 2 rounds. So what they did was they combined both pyruvates together and said 2 and 2. They left them, they didn't make them separate.
Well, that was non-confusing.
I know, they're evil bastards. Because if you look at what they're doing here, play down backwards. You had 2 of these, right? But they only show the 1 going through, but they double everything to confuse you. They're really nice. They would split it and do 2 at the same time. But they're creeps.
Or just do 1 and then times 2.
What do you want for $1 million in office fees? You know? Back to this one. So here we go on the Krebs cycle, TCA cycle, carboxylic acid cycle, citric acid cycle. So we're going to start at the top. We're going to take acetyl-CoA. From where? Where is that from? Over there. Right? And we're going to use it to make something. We're going to take oxaloacetic acid, or oxaloacetate, and we're going to make what? Let's see.
Citrate.
Acetyl-CoA plus that makes citrate, or citric acid. That's what they call it, citric acid cycle. So we took oxaloacetate with acetyl-CoA to make citrate. Great, nifty. What does citrate become? Let's find out. Citrate becomes this guy. We're just going to call him ketoglutarate for now. Ketoglutarate. So how do I go from citrate to ketoglutarate? What do I make when I do that? What am I going to make? What was it?
6 change sugars.
Let's see. I'm going to make that guy. What's that guy? NADH. And I'm going to make something else. What's just below my pen?
CO2.
CO2. And that's going to make ketoglutarate. Haven't lost you yet. Good. Okay. ketoglutarate goes around, magic happens, and you're going to become succinate. Can someone tell me what I make when I go from ketoglutarate to succinate? Let's take a guess. What do you think that is? NADH. Hey, I know this answer. What do you think comes along with NADH? CO2. And as a bonus, you get something else. No. An ATP. Wow, how about that? Almost done. Succinate becomes something else. Malate. What do I get when I go succinate to malate? What do I get? FADH2. Right there. And what do I get when I go malate to oxaloacetate again? What do I make? NADH again. Okay. There's sort of an easy way and a hard way to learn this. The hard way is just the sheer memorize. The easy way is every time you make a step, you make something with an H in it. NADH, NADH, FADH, NADH. Just know that one. So every step of the process, you're going to make something with letters. NNFN. How can we do it? Okay? But that's why you have to know all the steps, because each step makes something. As far as I got? Okay, so let's make it a little easier for you. What I would recommend you do, before not memorizing the gibberish, learn the easy way. Here's my Krebs cycle. It doesn't show the in-betweens. Let's see what I do. I take acetyl-CoA, and then what do I make when I go through the process? I'm going to make what? CO2s and what? NADHs and FADH2 and ATP. So at the minimum, just kind of learn that and then add the detail. So explain to me why, okay, this says 2, 3, and all that. But didn't this other one give you a different number? Why are they saying, gee, that's true, but some of the books will tell you that's double that number. Why is it double that number? Yeah, we have 2 of these. So we double everything. Why do I have 2 of those? Because I have 2 of these. So everything will be double, basically, what the diagrams usually show. So per round, I have 2 CO2s. Per sugar, I'm going to have 4. So I do it twice. Make sense? So don't let the number thing bother you.
So John, where do you get the 2-pyruvate from?
From glycolysis. We split the sugar into 2 pyruvates. H1 goes and makes it acetyl-CoA. So do it again our Krebs cycle.
So the question would be asked, like, how many CO2?
Right, so if I would really mean, you have to know if I'm asking per sugar, which is double, or per like pyruvate. So per pyruvate, you get what's on the board. If it's per sugar, you get twice what's on the board because you get 2 pyruvates per sugar. Make sense? So you have to sort of be careful if it's sugar or pyruvate. I will try to be as clear as I can on your exam. There's Krebs cycle.
You're not going to make us learn that you can get ATP from all those FADH blah, 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 as well?
Yes,
That's
we are.
the next step?
That's where we're at next. Thank you for an introduction. So, let's go to round 3. Here is my ETC, electron transport chain. All my erasers are gone. Luckily on this one, you don't have to actually learn much about the specifics. Let's go through what's happening. First off, what the heck are those NAD-FADH2s? Where'd they come from? From the Krebs cycle. So we're going to take our NADH and our FADH2 from our Krebs cycle. Magic's going to happen. What is the magic?